But this is, let's say, an average, typical environmental picture of the life cycle stages of a product. And of course, different products have completely different life cycle stages sometimes in environmental products. So this is to illustrate only what the average is. Very often there's quite some input in the raw materials you need to make products, like this laptop for instance. There's plastic, there's copper, etc. in it. And the more you put in, the more you can take out in the recycling phase, of course. But there is always a balancing act, because you should try to minimize the amount of materials you use for sustainability reasons, of course. Then is the production and assembly phase. We're converting our raw materials into printed circuit board and LCD screens. Sometimes goes a lot of energy and other auxiliary built in that. Then of course there's the use phase, which is usually the most dominant because these products consume electricity over their whole lifetime. And then you enter in the life cycle stages. So you can have like worst case disposal, like incinerating or landfilling it, or improper treatment for it. Or in the best possible case, you try to maximize the recovery of environmental but also economic value out of this process. Just to give you an idea on where the different life cycle stages are for electronics. And also that there's more to the recycling phase alone. So, now, to give you a bit of other pictures, this is 8 years ago. We started to see whether we can help in China to set up larger scale manual dismantling of electronics. And we started cooperating with a recycling plant for motor scrap. And this is what they're doing. Hammers, chisels, separate copper and steel, etc. Into rather clean fractions in the end. It may not look nice. Maybe it's a bit better than aqua glossy at the moment. But they do the recycling their way. And there's also a good reason for that. You probably know that. If you are a recycler, you definitely know that. On the right-hand side is typical, let's say, shredder output fraction from hard disks when you use mechanical separation. You basically have all the different elements. So the raw aluminum, the cast aluminum, the copper wire, the steel, the plastic, the circuit board, the magnet, that is attracting all the other steel elements, of course. And it's very hard to separate that in a mechanical way, specifically when there are magnets involved. On the left-hand side, you see the outcomes of manual dismantling. And you already see quite some elements, can be around 20 or so. So you do get a lot of fractions if you go very deep in your design. Now we were trying it at this facility that started rather primitive, simple tables like you will see above. But you do see that you get very clean fractions out of it. These are like the hardest stripes. They contain some nickel, but sometimes also specific precious metals on the surface, like platinum or rhodium. But you would never get out with any mechanical process. You just dissipate all over. Aluminum ring. Very interesting fraction also from, in this case, hard disk, is the neodymium magnets. They're very strong, so all the steel will attach to it. It's horrible if you have it in a shredder. This is worth around 30 euros, $40 per kilo. And if you can separate it, it can go back into the toy industry to make these pyramids and nice things, etc. Or, of course, back to the fuel magnets. So the advantage is that with this company we try to set up larger scale dismantling facilities with tables, with pneumatic tools. They also got working there, but we were talking here 2008, and there was not so much collection going on in China. Because the government program, or at least the old or new type of programs, were not running yet. So they basically couldn't really start the processing. And at the same time, there were some management issues, of course. You always have that. Also specifically in China, maybe. but also in the permitting side. You need basically 3 permits to do this on a large scale, and you only got 2. It's very hard to get the third one. You have to do other ones. So, just to illustrate a bit of where I'm coming from, this is typical output. But I will also show you the alternative here. And it's a nice video of the mechanical separation in the Netherlands like 10 years ago. Before you see the kind of development from rather rooms sitting on the ground type of dismantling to this better drift-proof German tables, etc. But also in the Netherlands, 10 years back, it's not all very nice. Well, I have to work on the ground. But just take a look. This is the shredding of the dismantling and then shredding and separation of steel in the Netherlands. They're treating like 400,000 or 500,000 pieces a year, and this is from 2002. You can see the logistics. And the interesting thing will come here. These guys are always in a hurry. Time is money. So here they have a nice dismantling line. So even from a health and safety perspective, like 10 years ago, there were some issues. They work around the route. They don't have much time available. But you also see how old the products are. The wooden casings. So at least they do have the protection. But this is kind of a mixture of, say, mechanical and manual work already. Well, look at this. So this is manual dismantling, and then the further shredding steps for the fractions that come out. Like here you see the electron extraction, and that then goes through shredding.
Okay. He's not afraid.
No.
He hit the wrong place.
And then let's just from encasing to get granulated and then separated, etc. Yeah, this is with a diamond saw, so they did split at that point in time screen glass from the cone glass, because they could still export cone to screen glass production, so that does make sense. But look how they are separating this. It's rather rude and it's also a bit risky here. You see, he has this globe still here. If there's such a screen, how about the upper part of your arm? And importantly, so they're not completely stupid, I would say, the fluorescent powders are being vacuum cleaned more or less. And the old fluorescent powders can still contain cadmium and lead, for instance. Yeah, this is also very interesting. What's in here? This was actually very dumb what they did. This was in the early days when they started to send out these CFT glass fractions. But they were scraping over the concrete. And there's one thing that you don't want in your CFT glass, that is all particles like concrete or stones, etc. And it's totally disrupting the quality of the process. So later they make a nice layer of CFT glass and then do it like this. But it was not so smart actually. And this is then being washed, milled into smaller pieces and sent out for new CFT production, which we don't have anymore. But I just show you to give you an impression that also in Europe or in the US or in China, there is a development process in this as well. And I think also for the developing countries, there is a development process to go from very rude to much more sophisticated and also faster and smarter ways of dismantling to really nice kind of demanufacturing plants. brings me to this. You're going to dismantle a specific product. And the exercise for today is to try to use that current table, the eco-efficiency diagram, to decide what kind of fractions are we making and what's the best destination for them actually. This is from a recent paper. You have a copy on your table above. Don't start reading all the scientific work, you just not first. But there are some nice figures in there that can help you to try to look for where should we go with all those fractions. What are the options we have? How can we basically optimize between what's available in the country you will select yourself, so what's available from the international markets like sophisticated end refineries or dedicated treatment of nutrient-containing parts, and so on and so on. So this will be the assignment, and I hope that after the dismantling exercise you can try to quantify on how to become a millionaire in a responsible way. So that's what you need to do. Think about what the current status is in the country you will select with your group. And try to come up with good improvements for separating certain materials or not, sending it to destinations. And I have some backgrounds for you. I'll come back to that later. Here are some background slides in your map. I'm not going to teach everything that's on it, but you can think about improvement areas related to the dismantling itself. How to do it more fast, how to do it safer than you do now. You can think about the cost also, but also the dismantling times and components. You will get an Excel file from Federico when you sit upstairs. Start filling in and try to determine what's actually the revenue I can get from recycling the supplies. Here are different, let's say, end processing options, I would say. So if you, for instance, have CRT glass, there are a few options where it could go to, but some of them are not good, of course. So try to select one of the pluses there. But these are basically compatibility tables showing from a materials point of view which materials you need to separate from each other or not. Don't try to get the whole idea and everything in mind, but try to use this to, you have certain fractions in what you will separate or not. Here's for the values and costs. You want to determine the total value of the product and the fractions that come out. Right? We have these tables to help you at least to make a European estimate. But it could be that your local values for these materials are much lower or higher. If that's the case, try to ask your SME in the group if you better numbers or better estimates, etc. It's just to try this out. Here are values also for components, because very often the dismantling is nice from a materials point of view, but sometimes there's no value in maybe the hard drive or floppy drive or the CPU or the battery, etc. in there that you could sell or reuse maybe on the market if it's not too old. So here's some values, again European values. If you have different values, it can be lower or higher in the country as well. Then try to estimate. And here are some issues related to kind of the local environment, health and safety. So what we'll ask you to do is not to do everything here. Try to take one of those slides from the background materials and really try to optimize on that. So make a decision there, which area. We have made a decision for you to who you will present. It can be, what was it, an inspectorate? Policy maker? So we have, and the presentation will be quite important. So don't try to make a very large scientific presentation. Really in short bullet points to the target person you will have to explain it to. you have to do one thing, that is, as a group, you have to select one of these improvement areas, and you have to select one geographical setting. So the country where you will do actual dismantling work in practice. And these are the groups. Upstairs is the here. And we have one extra exercise at the very end. When you go, there are two critical fractions. For one of them, and we have already listed them, try to do again the classification. And we also do it to start preparing for further, preparations for any notification work later. That's the idea. We can all go upstairs, there's protection equipment, find the right table, and I will shout some other things maybe you're there, and we'll just walk around. Any questions? Anything urgent or that you didn't understand so far?
Jaco, you'll talk upstairs also about the CRT and the LCD screws, so the
Yes,
safety
there's
part aspects of it.
specific safety things we'll discuss upstairs. Yeah. But the most important thing, try to keep everything intact. So be careful. Please.